Hi there, this is Derivatives 10 examples, and I'm just going to give some examples of some logarithmic functions and taking the derivatives of them. So let's start off. Y equals ln of cosine theta. Yeah. Therefore, we'll have our y prime, right, equals 1 over x, which is cosine theta, right? But then we need to also do the derivative of what was inside, which is the derivative of cosine, which is negative sine theta. This solution is going to equal negative sine theta over cosine theta, which is the same thing as negative tan theta. Same thing. There's your star. Alright, well, let's do another one. Let's switch it up. How about y equals cosine ln of x. We'll just switch it around, right? Well, y prime, you just do the derivative of the first, right? So that's negative sine of ln x. Then you multiply it by the derivative of what was inside, which is just 1 over x. So therefore, our solution is going to be, I would just put it as, let's do it this way, negative sine ln x all over x. And that's your solution. Pretty simple. Let's start with another one. Y equals log of x over x minus 1. Now remember, whenever you don't see anything down here where the a should be, just remember that nothing is the same thing as 10. So therefore, what was one of our identities that we remembered from way back when? It was that the log of x over a over b, log of a over b, would be the same thing as log a minus log b. So this is actually the same thing as log x minus log x minus 1. Same thing. I encourage you to do things like this to lighten your load. That way you don't get too stressed out about, oh, I have to do the quotient rule and the chain rule and so you just don't want to stress yourself out too much. You can really work around it and really lighten your load by just being a little proactive. So let's start off on this one. First of it, log of x, that's 1 over 1 times ln, right, of 10. And remember, 10 was the a that it's automatically there. So minus 1 over x, which is x minus 1, ln of 10 again. And I'll let you simplify that out, but you realize that there's really nothing to be intimidated by a lot of this. Let's just kick it over to another problem here. How about y is equal to x ln x? Well, that goes in. You get you can break it down pretty good, right? But just do it in your head. Derivative of the first one, we're doing the product rule, remember? So derivative of the first one variable is going to be just 1 times ln of x plus, you take the first one and then the derivative of the second, which is just going to be 1 over x. Well, you realize that these x's cancel out. So therefore, you have just ln of x plus 1. Aren't you happy that if we did that again, we would just get a higher number and a higher number and a higher number? It would just keep going forever, because look, we just went from x ln of x to ln of x plus 1. So we'll probably just continue on until we got something really odd and difficult to deal with. So just be happy that you have the easier way out here. So let's continue on. We can do one more. How about star? Let's do y equals ln x to the 4th sine squared x. Something really weird. So I mean, this is all really the same techniques, right? Y prime is going to equal, you just do, what's the derivative of ln of x? It's 1 over x, so 1 over x to the 4th sine squared x. So then you multiply that whole function by the derivative of what was inside. Well, derivative of what was inside is also a product rule, so gotta multiply it by the whole product rule. 4x cubed times sine squared x plus, then it's just x to the 4th power, right? X to the 4th times sine squared x. So you got to do the derivative of sine squared. What's that? It's just going to be 2 times sine. Well, let me just drop down a bit here so I don't run off the page here. I'm going to just drop down over here. Be 2, right? Sine. Just remember how to do this. X. You guys got it yet? So you got 2 sine x. You're just multiplying that 2 out, and you're leaving the sign there. And then you have to do the derivative of what was inside that, which is just 1. So the chain rule didn't really matter there. But then you also had to do a derivative of the sine, which is cosine. So you're also multiplying by cosine. So I know it's really hairy. We can simplify that out, but really, I mean, it's just multiplied onto that x to the 4th. So I'm just going to add that over here and cross it out up here. So you'll realize now that if you do this algebra, you'll have what seems to be really complicated, but wasn't too difficult to approach once you knew the systematic approach. So just realize, I'm going to just say, stick to your rules. Stick to your rules. Whether it's the product rule, the quotient rule, just stick to them. And that way you don't get overwhelmed. You just take it step at a time. 1, 2, 3. You can even write little numbers at it. Say, okay, I got to do the product rule first, and then the chain rule, and then just keep eating away at it. Try and hit it from different angles. So anyway, that's the examples of logarithms, and just be happy that you're not doing higher differentials in this one. So you have a good day, and I'll see you in the next video.